So here's a video on diagnosing a voltage output CiES fuel sender. So what you need is a power supply. Doesn't have to be a lab power supply, but something that will give you 12 to anywhere from 12 to 24 volts, depending upon the application. And then a digital voltometer that has a Hertz function on it. And you can see right there, Hertz. So I have a fuel sender hooked up, and it's relatively stable. When you move the arm, you go up the scale. This pin right here should always be on the right side when it's installed in the aircraft. Probably do a separate video of that. So anytime that you move that arm, you should get a change in Hertz on the screen. So, I've got an unstable output. Well, one of the reasons for that could be that your resistance to ground is not exactly your resistance to ground, or your power is not exactly what it's supposed to be. And let me illustrate. So now I have a decade box here, and again, let's look at the value. So we aren't changing that. That's going to remain stable there at that 85.2322. Well, let's add in, say, 4K resistance. Oh my, I got crap. That's what happens when you have too much resistance. You get values that range all over the map. Take it out again, turns right back to the stable and very easy and straightforward output. Now a reminder, the sender body is not grounded to the airframe in the normal sense. It is not the ground for the system. The black wire is the ground. We did this to eliminate the issues that we had, our people had, with grounding a rubber gasketed sender to the aircraft. So the ground that has to be grounded is here. The reference to grounding this unit does not provide adequate aircraft ground. It's there for lightning protection only. So let's take a look at what happens on the green wire. So we disconnect the blue, connect to the green, go here to the magic box and go over to voltage, and we get 1.5 volts, which is now changing with the position of the arm. Good. Again, we have 12 volts. So I'm going to change the voltage down. I'm going to run it down, and all of a sudden you'll see that all of a sudden this just starts becoming really goofy and unstable, but I'm down around 5 volts. That's what happens when you hook it up to a 5-volt supply and not aircraft supply. And as soon as you get to a reasonable number, which is about 9-10 volts, your values will stabilize again. But you saw that it took quite a bit of time. So again, turning it down, I get garbage. Turning it back up, I still get garbage, but then it'll stabilize and come to a set number. So let's go back to our handy dandy decade box and see what changing the ground does to this system. Yeah, only adding 200 ohms of resistance completely changes the output on the fuel sender. Take it away. A little bit of dancing around because we got peace. And you'll find that it'll stabilize itself back out on 169. Takes a bit of time. Again, just a little bit of resistance, I'm just going to put 100 ohms in, I get totally bad output. Take it away. Now the feedback loop is trying to find what the voltage is actually at, and then comes to a stable value. So what happens, Scott, if I remove the ground entirely? Well, I get this. And in fact, if I turn it up, I get no output whatsoever. What happens if I have a very high voltage, really high resistance? Again, I get pretty much garbage, but now once I remove it, it returns back to a stable value.